Hi everyone, it's Miss Costa here, and in this video we're going to go through some of the topics that could come up on the higher GCSE maths paper for Thursday. Okay, so in this question I am shown a right-angled triangle and told that all the angles are in degrees, and I need to work out the size of the smallest angle in the triangle. The triangle's angles has been given in relation to x, so likely I'm going to want to form myself an equation, solve it so that I can work out what the value of x is. So I know, first of all, that angles in a triangle sum to 180 degrees. And I've been told here it's a right angled triangle, which means that this angle here would be 90 degrees, which means that these two remaining angles will need to also add to 90 degrees, because 90 plus 90 gives you 180. So you know that 8x, which is the size of this angle here, plus 3x plus 13, which is the size of this angle here, must equal to 90 degrees. So you set yourself up the equation, then we see what we can simplify. We've got like terms here, 8x and 3x, so we can bring them together. 8 plus 3 is 11, so you're left with 11x plus 13 is 90. And then to solve that equation, we would subtract 13, so you'd be left with 11x equals 77. And the last part of the equation, to solve it, we would need to divide by 11. So you've got x is 7. Now we figured out what the value of x is, so we can substitute it back into our angles to figure out which one the largest angle must be. So here you've got 8 times 7, which is 56 degrees. And here you've got 3 times 7, which is 3x, plus 13. So 21 plus 13 is going to give you 34 degrees. So we want to work out the size of the smallest angle in the triangle, which would be 34 degrees. To double check that all of your angles work, just check if it all adds up to 180. So 56 plus 34, 6 plus 4 is 10, 5 plus 3 is 8, plus 1 is 90. So these two we know add up to 90, and your other angle is 90, so you know that it must be correct because the angles add up to the right amount. Okay, so in this question we are shown a square with perimeter 24 centimeters, and I need to work out the proportion of the area inside the square that is shaded, so this area here. And then once I've done that, I need to simplify my answer fully. So let's take a look at the information that I've been given. I've been told that this is a square with a perimeter of 24 centimeters. Now, a square is a quadrilateral that has 4 equal sides. So I know that this plus this plus this plus this must equal 24. So whatever this side is, 4 lots of it must equal 24 centimeters. So one side must be 6 centimeters. You could have done that without the algebra because you know that a square has four equal sides. So you just did 24 divided by 4. So we know that each of these sides is 6 centimeters. Now, if you figured that out, you can then figure out what the remaining little bits of the unshaded area would be. So if the whole side is 6 centimeters, this little bit here must be 2 centimeters, and this little bit here must be 3 centimeters because the sides need to add up to 6. So we need to work out the proportion of the area inside the square that is shaded. So this is a random quadrilateral. It's not a kite, it's not a parallelogram, so it will be much easier to work out the area of these two triangles and subtract them from the area of the square. In general, if you need to work out the shaded area of something, you work out the area of the large shape, so whatever the shaded area is in, take away the unshaded bits, would leave you with whatever the shaded area is. So if we work out the area of the square and then we subtract the area of triangle 1 and triangle 2, we would be left with whatever the area of the shaded bit is. So let's have a look at doing that. So first of all, we've got the area of the square is going to be pretty simple, base times height. So 6 times 6 is 36 centimeters squared. Next, we've got triangle 1. So it doesn't really matter which one's which. I'm just going to call this triangle 1. So we've got just a quick reminder, because people always or sometimes just forget to halve the area of the triangle. But the formula for the area of a triangle is base times height, and it's always the perpendicular height. So you're always looking to find a bit where the height and the base are at right angles to each other. So base times height and then divided by 2. So area of triangle 1 is going to be base is 3, height is 6, and then we're going to divide it by 2. So that would be 18 divided by 2, which would be 9 centimeters squared. And then the area of triangle 2 is 2 centimeters by 6 centimeters, because we know that the length of the side is 6. So 2 times 6 divided by 2 is 12 divided by 2, which is 6 centimeters squared. So to work out what the shaded area is, I'm going to do 36, which is the area of the square, take away area of triangle 1, take away area of triangle 2, and 9 plus 6 is 15, so that would become 36, take away 15, and just to be 100% sure, we can use the column method to subtract. So 6 take away 5 is 1, 3 take away 1 is 2, so that would be 21 centimeters squared. So this area here is 21 centimeters squared, and it's asked me to work out the proportion of the area inside the square that is shaded. So that basically means write the area, the unshaded area, as a fraction out of the whole area. Sorry, the shaded area. So the shaded area is 21 centimeters squared out of 36 centimeters squared. It says simplify your answer fully, so I'm going to look for something that divides into both 21 and 36, just simplifying equivalent fractions. And 3 is the easiest number, so 21 divided by 3 is 7, 36 divided by 3 is going to be 12. Try simplifying it again. 2, 3, 5, 7 don't fit into 7 or 12, so therefore this is going to be your simplest answer. Okay, so in this question, we are multiplying a decimal by another decimal. So the trick with questions like this is to multiply them by a power of 10, each part of the calculation, so that you can turn both parts of the calculation into whole numbers, because then it's a lot easier to multiply. So 52.3, I multiply that by 10, and it becomes 523. 5.6, if I multiply that by 10, becomes 56. So now I've turned my decimals into whole numbers, which I can multiply. So you can do whatever method you prefer. Most of the time I use Napier's bones, but we'll just do column method for now. So 6 times 3 is 18. 6 times 2 is 12. Carry the 1. 6 times 5 is 30. So that would be 31. Then we add a 0 because we're multiplying by 50. 5 times 3 is 15. 5 times 2 is 10, add the 1 is 11, and 5 times 5 is 25, add the 1 is 26. Add these two together. I haven't done this very well, should have done it the other way around, but it's fine. So 8, 3 plus 5 is 8, 1 plus 1 is 2, 3 plus 6 is 9, and 2. So I know that 523 times by 56 is 29,288. However, what I actually want to know is what 52.3 times 5.6 is. So the proper mathematical way, and the reason we've multiplied and then can do this trick, is because if I've multiplied this calculation by 10 and 10 again, I've actually times it by 100 to turn them into whole numbers. So what I need to do to go back is divide by 100. So I need to do 29,288 divided by 100, which would give me 292.88. Now, if this is last minute and you don't know how to multiply decimals, then the trick is, step 1, just turn them into whole numbers. Step 2, however many decimal points are after the digit in your calculation. So that's 1, that's 2. There's 2 digits after the decimal point in your calculation. That's how many digits are going to need to be after the decimal point in your answer. So whatever your whole number answer is, just think, okay, I'm going to need to put So you've got the digits 29288. You're like, okay, there were 2 digits in my calculation, so there's going to need to be 2 in my answer. Therefore, I know I'm going to put the decimal point there. That's a quick cheat way, but the reason is because we've multiplied by 100, so therefore we divide by 100 to get it back to the decimal form. Okay, so here we've got a question about inverse proportion. Inverse proportion is when one value rises, the other variable or value goes down. So for example, if you wanted to paint a room and you had one person helping you or one person doing it, it's going to take a lot longer than if 20 people came and all did a little patch of the room. So one person takes a long time, but if more people came, the time goes down. So inverse proportion is when one thing goes up, the other goes down. And it's the opposite of direct proportion. And for questions like these, people always get tricked. So think very, very carefully. If you're going to need to use inverse or direct proportion, think about it in real life. So in this case, we're told that it would take Macy 140 minutes to fill a swimming pool using water from 6 hoses. And how many minutes will it take to fill the pool if only 4 of the hoses were used? Well, there's going to be less hoses, so less water coming in, so it's going to take longer. So we can't use direct proportion, and that's when inverse proportion comes in. So let's first of all set up our equation. So we know that 6 hoses are going to take 140 minutes. Now, the best thing to do is to just work out, especially because this is non-calculated paper, work out how long one hose would take and then go from there. So with inverse proportion, it's the inverse to direct proportion. So whatever we do to one side, we're going to do the inverse operation to the other. So to get from 6 to 1, I'm dividing by 6. So therefore, on the other side, I'm going to need to multiply by 6 to figure out how long it would take. So whatever you do to one side, you do the inverse calculation on the other side. So I'm going to need to do 140 times by 6 to figure out how long it would take for one hose to fill the swimming pool. So 6 times 0 is 0, 6 times 4 is 24, and 6 times 1 is 6. Add the 2 is 840. So I don't know why I wrote one hoses. One hose would take 840 minutes. I then want to work out how long 4 hoses would take. So what do I do to get from 1 to 4? I multiply by 4, and therefore on this side I'm going to have to do the inverse, which is going to be divide by 4. So 840 divided by 4, 4's into 8 go twice, 4's into 4 go once, and 4's into 0 don't go. So that would be 210 minutes. So that would be your final answer. In the second part of the question, it says to state one assumption you made in working out your answer to part A. Well, we assumed that all the hoses are pouring water at the same rate, because if one was pouring it like a trickle, it's not going to be filling it up as quickly as the other one is. We're just assuming that all pouring out water at the same rate. So we'd say all of the hoses are pouring out water at the same rate. And we have to make those assumptions. We do make assumptions in everyday life, because otherwise there's too many variables and we can't just make a guess of how long something would take. But yeah, that is the key with inverse proportion. And with assumptions, just think, is there something that could be different and would change my answer to this calculation? Okay, so in this question, I'm told that Elion pays £15 for 12 watermelons, and that he then sells all 12 watermelons for £1.50 each. I then need to work out his percentage profit. So in general, for percentage profit, the formula is to work out what the new value is, or like the final value, which we are yet to do, subtract the original value, divide it by the original value, and times by 100. So the original value is £15. We need to work out what he manages to sell them for. So he sells 12 of the watermelons for £1.50 each. So I could either work out how much one watermelon is originally, or I know that originally they all cost £15. So probably it's going to be easier to just do 12 times £1.50 to work out their new value. So 12 times by £1.50, I could split it up just because this is non-calculator, it makes it easier. 12 times a pound is £12, and then 12 times 50 pence would be half of a pound, which is 6. So the new value, or what he sells them all for, the money he takes from all of his sales, is £18. So to substitute that into the percentage profit formula, I've got £18, take away the original value, which is 15, divided by the original value, and then times by 100. So that gives me 18 take away 15 is 3. So I'm left with 3/15. I could simplify that, divide by 3 for both numerator and denominator, which is 1/5. And then 1/5, if you didn't know that it was 20%, you could have done 1 divided by 5, turned it into a decimal. So 5s into 1 don't go, 5s into 10 go twice, and then you've got your decimal. Times it by 100 to turn a decimal into a percentage. But yeah, that's how we do percentage profit. Okay, so in this question, I'm given multiple means of different things. So I want to be very, very careful about what I do here. A common misconception is that people just think, oh, I'm going to add the two means together and divide by 2 or 3 or something. You don't do that. You have to work out the total weight of everything first. So that'll make a little bit more sense once I've explained it. So just in general, it always helps to write out what you know. So you know that to work out the mean, it's the total, and in this case we're dealing with weight. So total weight divided by the number of items, or the frequency. In this case we're dealing with blocks. So the mean is going to be the total weight divided by the number of blocks. And you've got a few means for all the different colours. So I'm told that 5 red blocks have a mean weight of 6 kilograms. 6 yellow blocks have a mean weight of 9, and 1 green block has a weight of 8 kilograms. Alex says the mean weight of the 12 blocks is less than 8 kilograms, and I need to decide if Alex is correct. So I essentially need to work out what the mean weight of the 12 blocks is. The way to do that is I'm going to need to work out what the total weight of all of the blocks are, and the only way I can do that is if I know what the total weight of the red blocks are, the total weight of the yellow blocks are, and the total weight of the green blocks are, which I know because I've been told it's 8 kilograms. So let's use this formula and put it into action. So the mean of the red blocks is 6. So it's going to be the total of red divided by 5, because there are 5 red blocks. So then I can just rearrange the formula, times both sides by 5. So that must mean that 30 is how much the red blocks weigh. So I know that red total is 30 kilograms. I then do the same with the yellow blocks. So I know that the mean of the yellow blocks is 9. The total of yellow divided by however many blocks there are, and there are 6. So that must mean I do 9 times 6, which is 54. So the total of the yellow blocks is 54 kilograms. So the yellow total is 54 kilograms. They've also told me that 1 green block has a mean weight of 8 kilograms. So I know that the green total is just going to be 8 kilograms. So now that I know the individual weights of all of the different blocks, now I can work out the overall mean of all of the blocks. So the overall mean is going to be the total weight. So it's going to be 30 plus 54 plus 8 divided by the number of blocks. So that's 5 plus 6 plus 1. Let's simplify it. So 30 plus 54 is going to give you 84. 84 plus 8 is going to be 92. So you've got 92, and then 5 plus 6 plus 1 is 12. So your overall mean is going to be 92 divided by 12. We want to simplify that, so let's divide it by 2. That would give you 46 over 6. Let's divide it by 2 again. That would be 23 over 3. And then we can just use short division. Oops, that's the wrong number. 3's into 23 to figure out what that is. 3's into 2 go none. 3's into 23 goes 7. Remainder 2. 3's into 20 go 3. Hold on. 3 times 6 is what I meant. 6 remainder 2. So it's going to be 7.6 recurring. So I know that the mean weight of all of the blocks, the mean is 7.6 recurring. So is Alex correct? Yes. Okay, so the other thing is when they give you questions like this where they say, is someone correct? You need to actually say whether they are or they are not correct. The amount of people that lose marks because they haven't said yes or no and then given a conclusion is quite a lot of people. So you say, you answer the question, you say yes or no, and then you give a reason. So yes, Alex is correct because 7.6 is less than 8 kilograms. And obviously you show all of your working, don't rub any of it out. I know I've been rubbing it out, but that's so that there's space. Keep everything because you want as much evidence as possible. Okay, in this question I am given a diagram with a cube and a sphere in it, and I'm told that the surface area of the cube is equal to the surface area of the sphere. And then I'm told to show that something. So the first thing when you've got questions like this is they're always going to give you some very, very important information. So they've told you that the surface area of the cube is equal, which you automatically know you're going to want to form an equation, to the surface area of the sphere. So first of all, hopefully you know how to work out the surface area of a cube. To work out surface area, you want to work out the area of every face of the solid that you have. Imagine you're dipping it in chocolate. Think about all of the faces that would get covered. So a cube is a 3D version of a square, and all of the sides are equal, and there are 6 sides. So you know that the surface area of any cube is always going to be whatever the side length is, which we can call x. I know that the area of one face would be x squared, and I know that there are 6 faces, so for any given cube the surface area of a cube is going to be 6x squared. So I know that the surface area of the cube is equal to the surface area of this sphere. Now they've given you the formula for a sphere, which is 4 pi r squared. We could spread that out if we want to, just if it's like to make it easier. So remember when in algebra, a number and a letter are next to each other. It means they're being multiplied. We don't write the multiplication sign, it's just implied if the number and the letter are next to each other. So we can split it apart just while I'm substituting the values in, because sometimes that makes it easier for some people. So I know that 6x squared must be equal to 4 times pi times the radius squared, and the radius of this sphere is 6 centimeters. So let's see what I could simplify there. Well, 6 squared is going to be 36. So let's just write that out so that you see each line step of the way. And then we could do 36 times 4. So 36 times by 4. 4 times 6 is 24. 4 times 3 is 12. Add the 1 is 144. So you know that 6x squared is equivalent to 144 pi. Now we want to see what we can do. So I haven't even bothered to see what they actually want from me yet, because that sometimes confuses people and it makes you work backwards. So whenever you see a show that question, just do what you think you would do to work out something. If your question has an X in it, generally the aim is going to be to solve it, to work out what the value of x is, or to at least write it in an expression. So show that x equals blah, 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 blah. So I know that what I want to do is figure out what x is, which means I want to get x on its own. So first things first is I could divide both sides by 6. So 144 divided by 6, 6 is into 14, go twice, remainder 2, 6 is into 24, go 4 times. So x squared is 24 pi. And then I need to give my answer in the form x equals, so what would the next step be? It would be to square root both sides because x is being squared. So x is going to be the square root of 24 pi. And is that what they want? Yeah, they want, they don't want us to simplify it anymore, so they just want us to show that x is the square root of 24 pi. They haven't asked me to simplify it, so even though it's a surd and you could simplify it, you don't need to. Although we could. So square root of 24 is the same as root 4 times by root 6. So that would be 2 root 6. But I don't think we need to because they haven't asked for it to be in its simplest form. So we're just going to say that k is 24. And that would be that question. Okay, so in this question, we are shown a frequency table and we are asked to work out an estimate for the mean amount of snow per day. Now, when we're estimating the mean from a frequency table, it's the same thing we do every single time. And they're going to give you a table. It's going to have class intervals. Well, if it's a grouped frequency table, it is. If it isn't, then it would just have numbers. So the way we read this is that we're dealing with the amount of snow and it's bunched into categories or class intervals so that we can separate how much snow fell when. Because the amount of snow that fell is between 0 and 50 centimetres, it would take a really long amount of time to list out this many days 0 centimetres fell, this many days 1 centimetre fell. It would just be really ineffective. So that's why we group the frequencies together and we just put them in intervals. So between 0 and 10 centimetres, there were 12 days where between 0 and 10 centimetres of snow fell. Now, this category here, it means 0 is less than or equal to the snow, which is less than 10. So if it was exactly 10 centimetres, it would actually land in this category here. But that's not necessary for this question, just a bit of side knowledge there. So when we get a frequency table, a grouped frequency table, you're always going to want to create an extra column for yourself. Well, really an extra 2. So one is going to be the midpoint. And then another would be the midpoint times by the frequency. So some people, they don't need to create the midpoint column. They might prefer to just cross this out and write 5. You do whatever you prefer, but generally this is the proper way that shows all of your working. So the midpoint of this class interval here, the way we work out the midpoint, we add the two values together and then divide by 2. 0 plus 10 is 10, divided by 2 is 5. 10 and 20, add them together is 30. 30 divided by 2 is 15. Or, because these are quite simple class intervals, we could just find the midway point there. So between 20 and 30 would be 25, then 35, and then 45. Quite simple here. And then for my final column, I'm just going to do the midpoint times by the frequency to figure out what the total amount of snow is. So because on 12 days between 0 and 10 centimetres of snow fell, the reason I used the midpoint is because I don't know if it was actually closer to 0 or closer to 10. I'm just taking an average, and the safest bet is to go for the midpoint. So I'm estimating that on 12 days around about 5 centimeters of snow fell, because that accounts for maybe on some days it was 8, maybe on some days it was 3. Anyway, that's why we do it. So we do midpoint times frequency, 12 times 5. So just if you're not, just a little trick is the doubling and the halving method. If you halve one part of your calculation, so let's say that's 6, and you double the other part of your calculation, you get the same answer. So sometimes if something is easily multiplied into a multiple of 10, you might want to use this trick just to help you. So 12 times 5 is 60. And then we'd do 8 times 15. So once again, we could use the doubling and halving, because if I doubled this, it would become 30. Halve this, 4 times 30 is a lot easier to do than 8 times 15 in your head. 5 times 25. Again, hopefully you could see one of these will double easily to 50. Well, that's not actually that helpful. Well, maybe the other way would be. So if I doubled 5, that becomes 10. Half 25 is 12.5. So that would be 125. So you just play about with it. It's not always going to be perfect. 3 times 35. We could just use the normal multiplication method. So 3 times 5 is 15. 3 times 3 is 9. Add the 1. So that would be 105. And then 2 times 45 is 90. So make sure that whatever, as you're going into the non-calculator paper, you definitely want to make sure that your multiplication is top notch, that you have lots of little tricks and you feel confident in whatever your method is. So when we have to work out an estimate for the mean from a grouped frequency table, what we do is we work out what the total estimated amount of snow is. We've used the midpoint, which is how we've worked out our estimates, but it's basically the end column, and we work out the total of that and we divide by the total frequency. And this is going to add 30 because we're told that the table collected the amount of snow that fell for 30 days. So 60 plus 120 is going to be 180. 125 plus 105 would be 230. So I'm just bunching like them in twos just to make it a little bit easier. And then I'm left with 90. So 180 plus 90 is 270. And then I'm left with 270 plus 230. 7 plus 3 is 10. 2, 4, 5. So 500. You could have added this in absolutely any way that you want. That's just one of the ways that you can make life a little bit easier for yourself. So what do? I'm going to do the large midpoint times frequency total, 500, divided by the frequency total, which is 30. And I need to give my answer to the nearest centimetre. So I'm going to simplify this as much as I can. So divide by 10 would become 50 divided by 3. Then I could just use short division. So 50 3's into 5, go once, remainder 2, 3's into 20, go 6, remainder 2. So we're going to end up with a recurring decimal. So that will be 6 recurring because it would keep on being 2 and I'll keep on getting 6. So it's 16.6 centimetres. And because we're dealing with grouped frequency, I don't need to worry about rounding it down because it's in real life, because I'm using an estimate. So I'm going to round it up like I normally would, just with numerical values. So to the nearest centimetre is 17 centimetres. But if you're ever worried about things like this, that's why your working out is so important. So the examiner will be able to see you did get the right answer. Maybe you just rounded it down because you thought it was real life. Okay, so we're dealing with simultaneous equations now. Now here we've been given a graph and we're told to use the graphs to solve the simultaneous equations. So what a lot of people do, this is a 1-mark question and they've told you to use the graphs. A lot of people ignore this and they still try and solve the simultaneous equations. You can, it's going to take you a very long time and it's not going to be a very good use of your exam time. Much better would be to actually use the graphs. How do you use a graph to solve any simultaneous equations? What that means is, where are the x and the y values the same? Well, the x and the y values are going to be the same at the point where the lines cross. So at the point of intersection on any graph, regardless of how it looks, that coordinate there at the point of intersection is how you'd solve your simultaneous equations. So let's just look at what this point of intersection here is. So it's 0, -2 is the point of intersection. So when x is 0, y is -2. That is all we need to do. Find the coordinate, which is 0, -2, and then say what the x and y values are accordingly. Remember that with coordinates, it's always the x value first and then the y value. Okay, so now we've got some actual simultaneous equations that there is no graph, and we're going to have to solve them the proper way. Well, not the proper way, but the algebraic way. So I've got two linear equations. They both have x and y variables, and sometimes, if you're very lucky, they're going to give you simultaneous equations where your x values in both of the equations are the same, or your y values are. You're not so lucky this time, but that's good because it means you can practice the hardest type of simultaneous equations. So none of our variables are the same, and ultimately, before we do anything, we need either our x values or our y values to have the same coefficient. So we decide whether we want to multiply our x's or our y's. I'm going to... It's always generally easier to deal with positive numbers. So I'm going to... Although this one would just be multiplying by 2. Okay, fine, never mind. So as we can see over here, we've got -4. If I just multiplied this by 2, then my y value would also be -4. So what I'm going to do, I'm going to write a minus times 2 in front of that equation to remind myself that this whole equation, I'm multiplying each part by 2. I'm doubling the whole equation by 2. So that would become 10x take 4y equals 46. And then this equation stays the same because I haven't done anything to it. So that remains as 3x minus 4y equals 25. Okay, so the first step is make sure choose either your x or your y values, and you want to make them have the same value. I could have times by 5 and 3 to make my x values the same, but that would have required a little bit more work. So the second step, once I've got my variables having the same coefficient, I need to decide whether I add or subtract the equations. So the way I decide this is I want to eliminate the variable that's the same. So I've made my y values the same, therefore I'm going to consider what's happening with the y values. So I'm either going to have to do -4 minus -4 or -4 plus -4. And to eliminate a variable, it needs to be equal to 0. So if I did -4 minus -4, that would become -4 plus 4, which equals 0. So that works. This would become -4 minus 4, which is -8. So it does not work. So therefore, that means I'm going to need to subtract my equations. So I'm going to put a giant subtraction sign here to remind me that I am subtracting the whole way through. So 10x takes 3x, leaves me with 7x. -4 minus -4 is nothing. It's 0. It eliminates itself. That's the whole point. And then 46 take away 25 is, let's just do a quick thing just because it's non-calc. We don't want to make any mistakes. 6 take away 5 is 1. 4 take away 2 is 2. So 7x is 21. Divide both sides by 7. Therefore, x is 3. So I've worked out that my x value is 3. And now what I need to do is substitute that back into one of my equations. It's generally always easiest to substitute it back into one of the original equations because they're going to be smaller. Doesn't really matter which one, but let's do the first one. So 5x is 5 times 3 minus 2y must equal 23. So 15 minus 2y equals 23. So minus 2y is going to be, I'm going to have to subtract 15 from both sides. So 23 take 15 is 3 take away 5, you can't do. 13 take away 5 is 8. So 23 take away 15 is 8. So minus 2y is 8. But we don't want a negative y, although in this case it doesn't fully matter because we can divide by minus 2. So we could have, if negative numbers confuse you and you're left with something like this at the end, you've got minus 2y. The trick is to multiply both sides by minus 1. So then that would give you 2y equals minus 8. It just might make it a little bit easier for other people. Some people, otherwise you could have done 8 divided by negative 2. Both would get you the same result. But either way, that then means that I can divide both sides by positive 2. So minus 8 divided by 2 is negative 4. So y is negative 4. So your final answer would be x is 3 and y is negative 4. If you wanted to, you could double check because then you definitely know that you've got it right. So if x is 3, double check by putting it into this equation. That would be 15. And if y is negative 4, minus 4 times by minus 4 is positive 16. So, x is 3, sorry. Yep, that's 9. 9 plus 16 is 25. Yes, it works. Okay, in this question, I'm told that Darcy recorded the number of cars going through her village every day for 120 days. Now I've got an incomplete table and an incomplete box plot, which give me information about her results. So the box plot's going to give me some of the information that I can use to fill in the table and vice versa. So part 1 is to use the information in the table to complete the box plot. Part 2 is use the information in the box plot to complete the table. So whenever I've got a box plot, it's always going to be exactly the same thing. And if you remember this, pretty much every box plot you'll be able to get right. So the lowest value is, it used to actually be called box and whisker diagram. And these things used to be called the whiskers. So like the end bits are your lowest value and your highest value. So that's what the box plot is missing. So I know that the least number is 250. And another thing that is really important is to work out the scale that the box plot is using. So I want to plot 250 on my box plot. Now halfway between 200 and 400 is 300. So I know that each 5 squares represents 100. So if 5 squares represent 100, one tiny little square is going to be 100 divided by 5, which is 20. So 250 is going to be like there, in between 40 and 60. Yeah. I mean, it's not great because it's on with a large pen on a small screen, but much more accurate if you do it on your paper. So I know the lowest value is 250, so I can just draw that there and connect it to my box plot. And then they've told me that the range is 1,100. So the range is going to be the distance between your largest value and your smallest value. That's the full range. So I could work out what my highest value must be. I do 1,100 plus 250, which would be 1,350. So I know that 1,300 would be here. So it's going up in 20s. So 1,320, 40, 60, 80. So 50 would be between 40 and 60. So I just draw it like that. Oops, that went too long. You don't want to slice through the highest value. Okay, so I've got my lowest value and my highest value. Then with box plots, you have this, let's rub this out actually. You've got the bottom part of the box, which is the lower quartile, and then the upper part of the box, which is the upper quartile. And essentially every box plot is split into quartiles. So this first bit here is your first quartile, from the lowest value to the lowest quartile. That's the first quarter of data. Then you've got your median, that's the next quarter of data. Then you go up to your upper quartile, which is the next quarter, and then you've got your largest value. That's why they're called quartiles, because they separate the lowest 25% and the highest 25% of data is represented by these parts here. But anyway, the lower quartile and the upper quartile are these things here. So I can read that from the graph. So the lower quartile, if this is 700, it would be 2, 4, 6, 8. So that would be 780. And the upper quartile would be here, which is 1200. So I've now used the box and the box plot and the table to fill in each other. Now, the next part of the question tells me that on some of these days, Darcy saw fewer than 780 cars going through her village. And I need to work out an estimate for the number of days that Darcy saw fewer than 780 cars going through her village. Now, this could seem like it's something very difficult, but what we have to bear in mind is that 780 also matches exactly with the value of the lower quartile. So remember that box plots are separated into quarters, and the lower quartile is this part here, and it has the value of 780. So that must mean that this bit here is worth 25% of the data. So I know that 25% of the days she saw fewer than 780 cars. So all I need to do is work out 25% of 120, which is the same as a quarter of 120. So that might be your preferable way, bearing in mind that these are quartiles. And a quarter of 120 is 12 divided by 4 is 3. So that would be 30 days. So people tend to leave these kinds of questions out because they're like, how am I supposed to do that? But generally it's going to be something related to the lower quartile or the upper quartile. Oh, and I've just realised I didn't draw on the median. The median is the middle bit here, and that was 1,100. So don't forget the median there. But yes, it would be related to the median, the lower quartile or the upper quartile. So the bottom 25%, 50%, or 75%. Okay, so here we have a question that relates to volume, area and length scale factor, which is something that's a commonly confused topic. So I'm told that A, B and C are 3 solid cones. Cone A has a volume of 27 centimeters cubed and cone B has a volume of 125 centimeters cubed. I'm then told that the radius of cone C is 200% of the radius of cone B. So you know already, if you're dealing with volume, and we're then going down to length because radius is a length. And then the next part of the question is talking about surface area, that we're most likely going to be involving the length, area, volume scale factors. So what that means is that with 3D solid shapes, if you know what the length scale factor is, it's going to be in a proportional ratio to the area scale factor and the volume scale factor, which in simple terms means that if the length scale factor, so like what you multiply, but let's do a very simple example. So let's say this was a triangle with base of 2 and you're enlarging it. You're multiplying this by 2. That would be the length scale factor. So length would be x. The area scale factor would then be x squared, and maybe I should have turned this into a square just to make life easier. So what would the area of this square be? 2 times 2 is 4. 4 times 4 is 16. So because the area is we're dealing with 2 dimensions, that's why the area scale factor would be whatever x is squared. And similarly, the volume scale factor would be x cubed, again to demonstrate with like just a random little square. If this was the volume, 2 cubed is 8 and 4 cubed is 64. So that's kind of why the scale factors end up being x and then x squared and x cubed, because each time you're multiplying by another dimension. But that's just a really, really brief whistle-stop tour of why that exists. Now, okay, so let's get back to the questions. So I need to think, I've got my cone A, I've got my cone B, and perhaps it could be helpful to write this out in a little table. So I'm dealing with 3 shapes and lots of scale factors. So I've got cone A, B, and cone C. And then I've got the length scale factor, the area scale factor, and the volume scale factor. So currently, the information I have is I know that the volume is 27 and that the volume of B is 125. And I know that because it's a cone, it's going to be proportional to its linear scale factor. So therefore, I need to do the cubed root of 27 and the cubed root of 125 to figure out what the length scale factor is. So the cubed root of 27 is 3. The cubed root of 125 is 5. So I use what I've been given to figure out what the length scale factor is. Now I'm told that the radius of cone C is 200% the radius of cone B. So it's going to be in proportion. The radius is going to be proportional to the volume of the cone. So I know that if this, the radius of cone B is 5, 200% of that would be doubling it. So the radius of cone C is going to be 10. I then need to work out the ratio of the surface area of cone A to the surface area of cone C. So I've got my linear scale factor, so that's x. So then I need to work out what x squared is. So x squared is 9, and for C, 10 squared is 100. So give your answer in the form A to B, where A and B are integers in their simplest form. It would be 9 to 100. I can't simplify that any further. Okay, so here I've got a histogram question. So I'm told that the table gives information about the amount of time that each of 150 people spent on a treadmill. So I'm first asked to draw a histogram for this information. So when I'm drawing a histogram, the really important thing that I need to remember, especially if you don't like remembering formulas, is that the area of the bar is equal to the frequency. So if you have issue remembering frequency density is the frequency over the class width and things like that, just think to yourself, the area of the bar is the frequency. If that is true, then that must mean that the class width times by the frequency density gives you the frequency. So that's actually not that helpful for you if you didn't know where the frequency density and class width are on a histogram, but it's still something. So on a histogram, our frequency density is always going to be the y-axis, okay? And then our class width, which are these class intervals here, is going to be your x-axis scale. So let's start off by trying to do some working out. I should have really left some more space. I thought I did, but I didn't. Okay. Anyway, we're going to work out what the frequency is. And I'm just going to have to make this go onto the histogram and then I'll rewrite it somewhere. So I want to work out the frequency density. And the way I do that, if I remember the formula, so I know that the area is the frequency. So that must mean to work out the frequency density, I'm going to do frequency divided by class width. So some of you might find it easier to just remember that formula. To work out frequency density, we just do frequency divided by a class width. So 70 divided by 10 is 7. That's the frequency density of my first class, so I'll just write it here actually. Then you've got 30 divided by 20, so that would be 3 over 2, which is 1.5. Then we've got 5, because from 30 to 35 is 5, so that's a bit of a smaller one. So we've got 24 divided by 5. So probably use bus stop for that. So 24 divided by 5. 5's into 20 go 4. Remainder 4. And 5's into 40 go 8. So that would be 4.8. Then we've got 12 divided by 15. So 12 over 15 I can write as a fraction. Simplify it by dividing by 3. So that would be 4/5, which is 0.8. If you didn't know that off the top of your head, then you could have just done 4 divided by 5 using short division. And then we've got 14 divided by 10, because the class width here is 10, and that would be 1.4. So let's just rewrite these here. This is frequency density. So it's 7, 1.5, 4.8, 0.8, and 1.4. Okay, so now I know what my frequency density is. Because I've been given nothing on this histogram, I'm going to need to decide what the scale is going to be. So I have 1, 2, 3, 4, 5 big blocks, and I know that my frequency density goes up to 4.8 is the highest value. No, it isn't. 7 is. Oh, that would have been a really nice little one. Okay, so 7 is the highest value, so that must mean that my scale must go up in 2s. So that would be 2, 4, I don't know why it's so big, 2, 4, 6, 8, 10. So halfway would be the odd numbers. So the really important thing is to make sure that your scale fits onto the diagram. So I've labelled my y-axis. Make sure that it's labelled frequency density. You're going to do it a lot neater because my space has been compromised. And then along here is where you do your class width. So it goes from 0 to 60. So we've got 1, 2, 3, 4, 5, 6. Okay, so we do have enough to give each 10, multiple of 10, its own place. So that would be 10, 20, 30, 40, 50, 60. Okay, so now we start drawing our bars. So our first bar, it has a frequency density of 7 and a class width of 10. So I'm going to go across 7 and to 10, and that's going to be my first bar. My next bar has a frequency density of 1.5, so it's going to be here, and a class width of 20, so it's going to go all the way to 30. So it's between 10 and 30 is the second bar, and between 0 and 10 is the first bar. Like, that's how you represent the class widths. Next we've got 30 to 35, so a really short one, and it's 4.8, so that's 4, that's 5, so 4.8 would be here, and then we draw that. Then we've got 0.8, which would be here, and that goes all the way from 35 to 50. And then we've got 50 to 60, which has a frequency density of 1.4, so 1.2.4. Okay, so there we've drawn our histogram. So the key is, step 1, work out what the frequency density is, because that's going to be your y-axis. The x-axis is your class widths, and then the area of the bars all represent the frequency. And the whole point of a histogram is going to be different areas. They're not going to be consistent like bar charts. Okay, so for part 2, it says work out an estimate for the fraction of these 150 people who were on the treadmill for between 20 and 40 minutes. So the reason it is an estimate is because we don't know where exactly the data is dispersed. We don't know if in this class interval here, for example, between 10 and 30, we don't know how many people actually did 11 minutes. It could be the case that all 30 people worked out for 11 minutes. We don't know, but what we do is we estimate that it's evenly distributed. So if we work out the area, if we know the frequency of the whole bar and we need a third of the bar, we're just going to estimate it as a third of the people. So we're going to do the same thing with between 20 minutes and 40 minutes. So between 20 minutes and 40 minutes is going to be these areas here. So the only one that is a full-on area by itself is this bar here. And we know that the frequency of 30 to 35 is 24. Now over here, it's half of this bar that we need. We need the interval between 20 and 30. So between 10 and 30 minutes, 30 people use a treadmill for between 10 and 30 minutes. So half of that is going to be 15. So this is 15 people. And then here we've got, this one's a little bit trickier. So it's between 35 and 50. And that is a gap of 15. So it's not that tricky actually. So we just need to work out a third of whatever this frequency of the bar is. So between 35 and 50 were 12 people. So a third of 12 is going to be 4. So that's going to be an estimate for how many people there were. So 15 plus 24 plus 4 is the same as 15 plus 28. Let's just quickly do 28 plus 15. 8 plus 5 is 3, 13. And 2 plus 1 is 3, plus 1 is 4. So that's 43 people. It says work out an estimate for the fraction of these 150 people. So you just say 43 out of 150. So yeah, that's pretty much histograms in a nutshell. Okay, so now back to a little bit of algebra. We've got some fractional and negative indices. So there are just some key points to quickly recap. So if you've got something like this, let's say we've got 8 to the power of 2/3. What the denominator means is this is what I want to take the root of. So if it's a 3 at the bottom, you want the cube root. If it's a 2 at the bottom, you're going to want the square root. If it's a 4 at the bottom, it's going to be the 4th root, but it's very rarely going to be that. So generally, the denominator tells you what root you're taking it to, and the numerator tells you what power you're taking it to. So for example, we'd rewrite this as the cubed root of 8, then taken to the power of 2. So you can do it bit by bit. So the cubed root of 8 is 2, so that would be 2 squared, which is 4. Okay, so this becomes 2, and then you square it. So you first do the root, and then you do it to the power of. So that's a recap for the first bit. Now for the second bit is that when you've got negative indices, so let's say you've got something like this. A negative indice means you want the reciprocal. So 5 to the power of minus 1 is going to be 1 over 5 to the power of 1. Which is the reciprocal. If you had 5 to the power of minus 2, it would be 1 over 5 squared. So you're taking the reciprocal of what it is. So 1 over 5 squared, you could then turn that into 1 over 25. But this is a fraction, so reciprocal makes a little bit more sense when you see the fraction. So you've got a third, and it's to the power of minus 3. What do I do? It's a negative, so I'm going to take the reciprocal, and with a fraction, the reciprocal just means you flip it over. With a whole number, the reciprocal is 1 over that thing. So it's 3 over 1 to the power of 3. So then each part you would cube, so that would become 3 cubed over 1 cubed. But anyway, let's take the whole question as a whole. So we've got 64 to the power of 2/3. So that means I'm going to do the cubed root of 64 because of that denominator here. It's going to be the cubed root, and then it's going to be to the power of 2. So I'm going to do that plus 1/3 to the power of -3. So when I see a minus, I know it's the reciprocal that I need. So that would be 3 over 1 to the power of 3. So you basically do the reciprocal and then it's the positive power of that thing. So the cubed root of 64 is 4. So I'm left with 4 squared plus 3 cubed, which is 27, over 1 cubed, which is 1. So 4 squared, which is 16, plus 27 is going to be your answer. 27 plus 16, 6 plus 7 is 3, 13. 2 plus 1 is 3, plus 1 is 4. So your final answer would be 43, and it says work out the value. So whenever you need to work out the value of something, it means the actual numerical value. Okay, so in this question, I've been given 2 equations and I've been told that they are perpendicular to each other. Now, the key thing that you need to know about perpendicular lines is, and perpendicular lines are lines that meet at right angles. So perpendicular lines, there's a special property they have, which is their gradients multiply to make -1, or their gradients are negative reciprocals of one another, whichever you prefer. So that's one thing that we really need to bear in mind whenever we see the fact that 2 lines are perpendicular. The next is that if you see an equation of a line, you should always think to yourself, okay, how do I write the equation of any given line? It's y equals mx plus c, where m is the gradient and c is the y-intercept. So we can use all of this information to do something with our lines. Now, our first line is very simple, is y equals 2x minus 7. So the gradient of line 1 has been given to us. The gradient is always the coefficient of x when the equation is in the form singular y equals mx plus c. So the gradient of line 1 is 2. That means that I can easily work out what the gradient of line 2 is, because it's the negative reciprocal. So 2 times by something must give me -1. The reciprocal of 2 is 1/2. It's going to have to be -1/2. So the gradient of line 2 is -1/2. So I can use this to start building up my equation. So I know that line 2 is going to be y equals -1/2 x plus c once I've done some manipulation of it. Now, the equation of line 2 has been given to me in not the nicest form. They could have given it to me in this form where y equals mx plus c and the gradient would be self-evident, but they haven't. So it's going to be up to me to rearrange this so that I can do something so I can compare the gradient and figure out what m is. Well, actually they want the value of k, but yeah. So there's a few ways I can do this, but the simplest way is probably rearrange the equation so that you've got it in the form y equals something. So at the moment it's 10y plus kx minus 30 equals 0. We're just going to move this part here onto the other side. So 10y equals minus kx plus 30, because it's the inverse. I would have had to subtract kx and I would have had to add 30. Now what I can do is divide by 10, because I want to get y on its own. So y would be minus k over 10x plus 3. I mean, the y-intercept doesn't matter so much, but we may as well. So I know that minus k over 10 must be equal to minus a half, because I have worked out over here that the gradient of line 2 is minus a half. So essentially, let's make these two fractions equivalent. So a half, to make it something out of 10, what have I done? I've times by 5, so I'm going to have to do the same thing here. So if these two are equal, then k must equal 5. Okay, so now we've got a circle theorems question. So it's really important that you know all of your circle theorems, because you're going to be drawing from memory and trying to figure out which one you're going to use here. So I'm told that A, B and C are points on a circle centre O, CD is a tangent to the circle, angle BCT is 50 degrees, and I know that angle OAB is 4 times whatever angle OAC is. And I need to work out the size of angle ACD. So ACD is this whole angle here. So that's helpful to know, because that's what I'm working towards. Okay, so let's figure out what we already know. We're told we know that angle BCD, so this angle here, is 50 degrees. Now, this angle is between a tangent and a chord within the circle. So this is actually one of the hardest for most people circle theorem to spot. It's the alternate segment theorem, and it's essentially whenever you see a tangent and you see okay, that circle's not touching it, and you see it's touching a circle, the angle between the chord and the tangent is going to be equal to the angle in the alternate segment, which essentially means it's most likely going to be a triangle, and it's going to be the angle that is not touched by the chord. So the chord is here, so it can't be this angle here or this angle here. It's going to have to be the angle in the alternate segment, so the angle that is not touched by the chord that creates this thing in the first place. So using the alternate segment theorem, I know that angle ACB, this big angle here, must also be 50 degrees. So that's the first thing that you use. And it says write down any circle theorems that you use. So you could just even annotate it as alternate segment theorem, but to be, you know, to show your full working out, you would say angle ACB is 50 degrees because of the alternate segment theorem. So we know that. The next thing that we know is that angle OAB, so this angle here, is 4 times angle OAC, which would be this angle here. So essentially this 50 degrees is being split up into these two angles here. Now, if you don't intrinsically know what to do, the best thing would be to form an algebraic expression. So I don't know what angle OAC is. I could call it x, and I know that angle OAB is going to be 4 times by x. So therefore, I know that x plus 4x must equal to 50 degrees, because I've been told that this whole angle here is 50 degrees due to the alternate segment theorem. So therefore, 5x is 50 and x must be 10 degrees. So angle OAC must be 10 degrees and OAB must be 40 degrees. So that's 10 degrees. We can write about x and 4x actually. 10 degrees and 40 degrees. Okay, so we've used the alternate segment theorem to figure out what these angles here are. Now the next thing is that this here, if this is the centre of the circle, then OA and OB must both be radii. And radii is just the plural of radius, so they are 2 radii, which means that this is an isosceles triangle, and the base angles of an isosceles triangle are equal. So we'd say triangle, well, I don't know, there's not enough space for working. Okay, so I'd say triangle OAB is isosceles as it's formed by two radii. It's not a circle theorem, but it's just extra reasoning. And actually, this is only a 3-mark question, so perhaps you don't need that. But it's just, if you hadn't spotted that it's an isosceles, whenever a triangle is formed by two radii, it's always going to be isosceles. So that's another little step in your circle theorem armor that you need. So if this is 40 and this is 40, I know that angles in a triangle sum to 180. So 180 take away 80 is 100. So I know that this angle here is going to be 100 degrees. Now, I know that the angle at the center is double that, the angle at the circumference. So that's the other circle theorem that I would use, is the angle at center is double the angle at circumference. And the way to spot this is, are the two angles formed by the same arc? So here you've got a rough sketch of this. And now let's think, this is angle that's 100 degrees. And if we look at the endpoints on the circle, what arc is formed by these two endpoints? Is this arc here. Now this angle here is the angle at the circumference, and let's go follow the lines. They meet at the same points. So what arc is formed by its endpoints or by the angle? It is this same arc here. So therefore these two are going to be your angle at the center and angle at the circumference. So if this is 100 degrees, we know that this angle here is 50 degrees due to the angle at the center circle theorem. So the final step is angle ACD must be these two parts here. So ACD is 50 plus 50, which is 100 degrees. The circle theorems that you used would have been the alternate segment, and then here, if you're super lazy, but I wouldn't recommend, you could have just said angle at circumference is double angle, angle at the circumference, because it's the other way around, is half angle at the center. And that's how we do that question. Okay, so here we've got a slightly tricky direct proportion and inverse proportion and creating a formula question. So it's a combining direct proportion, inverse proportion, and a little bit further. So let's have a look at what is happening. So it's really helpful if you remember your direct proportion and your inverse proportion general formulas. So the general formula for direct proportion would be y equals kx, and the general formula for inverse proportion is y equals k over x. So it's just good to have those two in mind as we do these questions, because there's so much going on in an exam, and sometimes you might just accidentally write one as a direct proportion just because you're trying to rush through it. So we're told that y is directly proportional to the square root of a. Now I like to write the proportionality statement, but some people this confuses them. So if this confuses you, then ignore it and just go straight to the equation. But this little sign here just means is directly proportional to, and I just like it because sometimes it's going to be the square root of a, sometimes it will be the cube of x, things like that. So it just helps to lay it out. We then turn it into the formula. So if it's directly proportional to the square root of a, it must mean it's equal to the square root of a multiplied by something, which is where k comes in. So y must equal k root a. And now that I've got my general statement set up, I can start substituting the values that I've been given. So when y is 20, a is 16. So 20 equals k root 16. So 20 equals 4k. So therefore k would be 20 divided by 4, which is 5. So I know k is 5. Your goal for substituting these values in, you sub them so that you can find the value of k, because we need the value of k to find out what the general equation for this specific question is. So the value of k is 5. So for my direct proportion part of the question, the formula is, or the equation is, y equals 5 root a. Okay, so that's the first part of the question. Now we're going to do the inverse proportion part. So a is inversely proportional to the cube of x. Again, just because some people might get confused when they're doing this, it might be helpful to annotate your question with like just how you'd write it out mathematically. So a is directly proportional to the inverse of the cube of x. That's your proportionality statement. Again, ignore it if it confuses you. Just go straight to the equation. A must equal k over x cubed. So this is the general formula, but obviously if it's x squared, if it's x cubed, you manipulate it accordingly. So I know that a must equal k over x cubed, and I know that a is 12.5 when x is 2. So 12.5 must equal k over 8, because 2 cubed is 8. And I'm going to need to do 12.5 times 8. So remember the doubling and halving method. If I double one thing, so double this, I halve this, and I'd get the same answer. So 25 times by 4 is 100. So therefore 12.5 times 8 must also be 100. So k must equal 100. So therefore we substitute it into the general equation. So a must equal 100 over x cubed. So if you managed to get that far, well done, because that's like, you know, the bulk of the question. So I've now got two parts of what I need. So let's just rewrite this. I know that y equals 5 root a, and I also know that a equals 100 over x cubed. Now the next part of the question is saying find a formula for y in terms of x. So I'm finding a formula for y, so I'm going to start with y equals, and I know that this bit here must have x values. So how can I do that? Well, I have the beginning of the equation here. I know that y equals 5 root a. That doesn't help me too much because it's saying write a formula for y in terms of x. However, what I do have is over here, I have what the value of a is. So I know that a is equal to 100 over x cubed. Now, if a is equal to 100 over x cubed, wherever I see an a, I can substitute this in, and then it's going to be in terms of x. So y is 5 to the root of 100 over x cubed, because that has the same value as a. So let's break this up a little bit. The whole thing is square rooted. It might make it easier for you if you just took each part individually. So we can break that up because it's the same thing. These are equivalent fractions like this. So the square root of 100 is 10. And this, we can't really simplify it and make it any nicer. So we can just leave it like that. So we'd be left with 5 times 10 over the root of x cubed. And 5 over 1 is what it would be if we wrote it as a fraction. So that would become 50 over x cubed, the root of x cubed. So that's how we turn the equations that we've been given into a formula. So the final part is y equals 50 over the root of x cubed. And this way, all I've done is I've brought the two equations together. I've substituted where I see a, I've substituted what the value of a is. So that's how you combine the two. And that's that for that question. Okay, so in this question we're dealing with inverse functions, and we're asked to show that. So show that means that we are given the answer. We know the final answer is going to be 4, and we just want to show each step of our working, show the examiner we know exactly how to get to the final answer. So I'm told that f of x is 2x cubed minus 8, and I need to show that the inverse of f of 120 is 4. So I need to work out the inverse of this function. There are a few ways that you can do it. You can either do it the function machine way, so going forwards and backwards, or a shortcut method is we replace f of x with y. So we're going to say y equals 2x cubed minus 8. And then what we do is we switch the x and the y variables around. So x is 2y cubed minus 8. And now what we do is we try and rearrange this equation to make y the subject again. So you've got x plus 8. I'm jumping too far ahead. So I'm going to add 8 to both sides, first of all. So x plus 8 is 2y cubed. The next step would be to divide both sides by 2. So x plus 8 over 2 is y cubed. And then the final step would be to do the cubed root of both sides. So the cubed root of x plus 8 over 2 is y. Now I've switched y and x over. So I now have y equals the cubed root of x plus 8 over 2. And the final step is, instead of saying y, we're going to say f of x equals the cubed root of x plus 8 over 2. So to explain exactly why this happens would be quite long-winded. The shortcut steps are you write out the equation, make it y equals something, switch the x and the y variables, and then you rearrange it to make x your subject. And then you, instead of saying y equals, you just switch that to f of x at the end. So that's how you'd find the inverse. So actually this is f of minus 1x, sorry. So this is the inverse function. So it's basically, what steps would you take for this function to be what it is? You take the opposite steps to find the inverse function. So f of minus 1, or sorry, the inverse of x is the cubed root of x plus 8 over 2. So I need to show that when x is 120, that my final answer is 4. So all I do is wherever I see an x, I'm going to put 120 instead. So all I've done, where is an x, I'm putting 120 instead. And now I work this out. So it would be the cubed root of 128 over 2, which would simplify to the cubed root of 64. And the cubed root of 64 is 4. So that is how you would show that, the inverse of x, and when x is 120, the final solution is 4. Now here we've got some composite functions, so that's where you're putting a function into a function, and I'm told that the function of g of x is h at x plus 3 and h of x is x squared. Now I'm asked to find the values of x for which hg of x equals this. So the first thing with composite functions is you start from the inside out. So I'm going to start from g of x. So it's g of x I'm going to put into h of x. So g of x is x plus 3, and I'm going to put this into h of x. So h of x is x squared. So I'm putting, instead of x, I'm going to be putting x plus 3. I'm putting g of x, the whole function, which is this, wherever I see an x in h of x. So h of x is x squared. So hg of x, remember I'm putting g of x into h of x. So that would be x plus 3 squared. So let's figure out what that is. Let's just expand the brackets. That would be x squared plus 6x plus 9. So I know that that is what hg of x is. So let's put that over here. I know that x squared plus 6x plus 9 must be equal to whatever they've said here, which is 3x squared minus 3x plus 19. So once you've done like the function-y bit, knowing what the composite functions are, how to put one into the other bit, this next bit is just algebra. You've got a quadratic on one side and a quadratic on the other side. And when that happens, all you need to do is rearrange it to make it equal to 0 and then factorize it. And then you have solved it. Your solutions are going to be the inverse of whatever's in this bracket. So let's have a go at doing that. I'm going to rearrange this so that I've got 0 on one side and the quadratic on the other. So first of all, I'm going to subtract x squared from both sides. So I'll be left with 6x plus 9 is 2x squared minus 3x plus 19. Then what can I do? I'm going to take away 6x. So 9 is going to equal 2x squared minus 9x plus 19. And the final part, I'm going to take away 9. So 0 equals 2x squared minus 9x, and 19 minus 9 is positive 10. So here's my quadratic. I'm just going to write that up here to remember, because we're going to need to do some more stuff. So 2x squared minus 9x plus 10 equals 0. So this is a quadratic. If it was a quadratic that had a coefficient of 1, x squared, then we could factorize it quite easily. But the coefficient of x is more than 1. So you do whatever factorizing method works best for you. But generally, I mean, yeah, let's do that one. So what do? I multiply the coefficient. Every quadratic is written in the form ax squared plus bx plus c equals 0. I multiply a times c, which is 20. Find the factors of 20. So 1 times 20, 2 times 10, 4 times 5. And I know that these factors are going to need to add or subtract to make minus 9. So because it's a minus 9, I know that one of the factors at least is going to have to be a negative. But because they need to multiply to make 10, I know that they both must be negative, because a negative times by a negative gives you a positive answer. So the two factors would be 4 and 5, because minus 4 minus 5 is a minus 9. And minus 4 times minus 5 is positive 20. So what I do, I write it out here. Minus 9x plus 10 equals 0. Now I've identified that my factors are minus 4 and minus 5, and the whole point here is I'm trying to split this up into two parts to make it easier to factorize. So which of minus 4 or minus 5 would factorize better with 2x squared? Well, 4x would. So I'd write the minus 4x first, because then the minus 5x pairs with the 10. Hopefully you've done this method before, and this is just a recap. So then what we do is we factorize this part. So 2x, x minus 2, and then we factorize this part. So if I had minus 5 on the outside, that would be x minus 2 over here, because remember, a negative times by negative gives you a positive answer. And ideally, well, it's not just ideal. If it doesn't, then it's wrong. What needs to happen is these two brackets need to be the same. They are the repeated brackets. And to factorize it fully, as in like the final step, you take the bits that are outside the bracket and you put it in one bracket, and then you take the repeated bracket and that's your other bracket. So this expression, or this quadratic, factorized is 2x minus 5 and x minus 2. So we've got 2x minus 5, x minus 2 equals 0. And to finish off the quadratic factorization, I make each bracket equal to 0. So 2x minus 5 equals 0. That must mean that 2x is 5, which must mean that x is equal to 5 over 2. Similarly, if x minus 2 is 0, then x must be equal to 2. So the values of x for which hg of x is equal to this are x is 2.5 and x is 2. Okay, in this question, we are dealing with surds, and whenever you're dealing with surds, generally you're going to be rationalizing the denominator. Not always, but if you see something like this, you're told to show that this can be written in the form this, which means simplify it. And to simplify a surd, if it has a surd part as the denominator, we need to rationalize it. And all rationalize means is eliminate the surd part. We want a denominator that is a rational number. So very, very, very quick recap of what we do. If we had something like 3 root 7, we would multiply by root 7 over root 7. The reason we do the same is because we want to keep the fraction proportional. So whatever we multiply numerator by, we multiply the denominator by. The reason we do this is because root 7 times root 7 would become 7. So a surd times by itself becomes its unsurd self. And that is how we do the simple surds rationalizing. But when you've got something like this, so let's say we had 3 over 1 plus root 2, what we need to multiply is by the conjugate, which essentially means this same thing with just the sign switched over. Okay, so that's just a very quick reminder of how we do rationalizing surds. So let's apply this, and then obviously with the harder ones, with the conjugates, you have to expand the double brackets and all of that, but that's what we're going to go through now. So I've got a surd here, and it's got a surd part as its denominator. So I know that to simplify the surd, I'm going to need to rationalize its denominator. There's 2 parts to it, so I'm going to have to use the conjugate, which is the same numerical values, we just switch the sign. Okay, so that's the first part to rationalize. So now I'm going to have 2 sets of double brackets, which might be slightly annoying, but it's just part of the process. So let's expand. And the reason we multiply by the conjugate is because we're always going to get the middle 2 terms eliminate themselves, and those middle 2 terms are always the surd part. So we've got 8 times 5. Also, if expanding brackets is not your forte, I would really recommend using the grid method and just setting it up like that for yourself. It just means you're not going to miss any smaller parts up. But I'm trying to keep this as brief as I can, so I'm just going to do it the shortcut way. So 8 times 5 is 40. 8 times minus root 3 would be minus 8 root 3. Root 12 times 5 would be 5 root 12, and root 12 times minus root 3 would be minus root 36. Then 5 times 5 is 25. 5 times minus 3 is minus 5 root 3. Root 3 times 5 would be plus 5 root 3, and root 3 times minus root 3 would be minus 3. So let's simplify this top bit. Okay, now already I can see a common misconception that might happen. So first of all, let's simplify the denominator. So 25 minus 3 is what your denominator would end up being, which is over root 22, because minus 5 plus 5 root 3, they cancel each other out. That's the whole point of rationalizing the denominator. The middle 2 terms are always going to cancel each other out. So I know my denominator is over 3. Now, here is where I'm going to want to do some working out to the side, because over here I've got 5 root 12 and here I've got root 3. So they're not like terms, which must mean that one of them hasn't been fully simplified. So root 12, how am I going to simplify that? Remember, you're always looking for the largest square number that fits into the surd. So what are your square numbers that are under 12? 1, 4 and 9. Which of those multiplies to make 12? 4. So I can write root 12 as root 4 times root 3, which is 2 root 3. So 2 root 3 instead of root 12. So remember that it's 5 root 12. So 5 times root 12, I'm going to change root 12 to 2 root 3. So that would become 10 root 3. So I could rewrite this as 10 root 3. Now, what has happened is I've got my denominator here, which is 22, and I've got 40 and minus root 36, which is 6, and I've got minus 8 root 3 plus 10 root 3, so minus 8 root 3 plus 10 root 3, minus 8 plus 10 is positive 2. So 40 take away 6 is going to be 34, and plus 2 root 3. So I am going a little bit quickly now because I know how long this video has become. So this is what I've got. Now they said show that this can be written in the form a root 3 over b, where a and b are integers. Yeah, so just be very careful. So we just want to simplify this. We don't want there to be a 2 in front of the root 3. So let's just divide the surd by 2. So 34 divided by 2 is 17 plus root 3 over 11. So we've recognised that 2 can divide into the numerator and the denominator. So I'm still keeping it in the correct proportion. And that is how we would show that. So A is 17 and B is 11. So hopefully that made sense. Okay, so in this question, I'm told that n is an integer such that 3n minus 3 is less than or equal to 12, and 8n over n squared plus 7 is greater than 1. Find all the possible values of n. Hopefully you notice that you're dealing with inequalities here due to these signs over here, and the fact that there's an n squared suggests that we're going to be dealing with a quadratic inequality as well. So the first step could be that we just work with the first inequality we've been given, which is a linear inequality, and it's pretty simple to solve. So 3n minus 3 is less than or equal to 12. Let's solve this to figure out what the value of n would be. I add 3 to both sides, so I know that 3n must be less than or equal to 15, and then I'm going to divide by 3. So n must be less than or equal to 5. So I know that first part. The next part is where it gets a little bit trickier. So let's just keep that stored up here. So n is less than or equal to 5 is the first bit. And now let's look at our next inequality here. So I know that 8n over n squared plus 7 must be greater than 1. Now I'm going to rearrange this to put it in the form of a quadratic where 0 is going to be greater than or less than something. So first step, I'm going to multiply both sides by my denominator. So multiply by n squared plus 7. So 8n is greater than n squared plus 7. Next step, I can subtract 8n from both sides. So 0 must be greater than n squared minus 8n plus 7. I just squished the 8n into here so that it's in the normal quadratic form, which is ax squared plus bx plus c. So you always want your quadratic, your square number first, then the number with a coefficient, and then your constant. Okay, so I've got it in the form of a quadratic. Whenever you're dealing with quadratics, generally, the thing you're going to need to do is rearrange it, make it equal to 0, factorize it, and solve. So I know that n squared minus 8n plus 7 must be less than 0. I've just switched this sign and moved everything from one side to the other. If 0 is greater than the quadratic, then the quadratic must be less than 0. So let's see what we can do. I've made it, if it was a normal quadratic, I'd make it equal to 0. This is an inequality, but it's still a quadratic, so I know that it is less than 0. I can still factorize as normal. So thankfully it's a simple quadratic. So I'm looking for two numbers that multiply to make 7 and add to make minus 8. The only factors of 7 are 7 and 1 because it's a prime number, and because I need to make minus 8, I know they're both going to need to be negative numbers. So it's going to be n minus 7, n minus 1 is less than 0. So with quadratic inequalities, it's not as simple as with your linear equations. With the linear equation, we'd say n is 7, n is 1. But with a quadratic inequality, what we're saying is we want to know where this quadratic is less than 0. So our critical values are when n is 1 and n is 7. So let's just draw a quick little axes here. 1, 7, and you've got a quadratic. So your quadratic is going to look something like this. These are the roots of your quadratic where they cross the x-axis. So what part of the graph is when the y values are less than 0? So this is your y-axis, and it's this part here where the graph is less than 0. So that means that it's in between 1 and 7 that we want that the value of x must be, or n, sorry. So we know that 1 is less than n, which is less than 7. I am rushing through this a little bit. If you've never done quadratic inequalities, then recap on that and this will make a lot more sense. So using my graph, I know that 1 is less than n, which is less than 7. I also know from previous working out that n is less than or equal to 5. So here, if I imagined I've got 1, 2, 3, 4, 5, 6, 7, I know n has to be less than or equal to 5. So that already gets rid of these two. I know that 1 is less than n, and I know that n is an integer, which means a whole number. So I know it can't be 1 because it's less than 1. So the only values it could be would be 2, 3, 4, and 5, because here it says it's less than or equal to 5, which means it could be 5 or anything less. But here I'm restricted by the fact that n is greater than 1. So the possible values of n would be 2, 3, 4, and 5. Okay, so in this question, we're dealing with probability problem, and if it's looking like it might be quite a tricky question, there is a chance that there might be some algebra involved. So let's have a look. We're told that Cannon has an empty bag. He puts some yellow marbles and some green marbles into the bag. So let's just try and visualize it. We've got a bag and it's filled with, well, I don't have yellow, but an unknown quantity of yellow and an unknown quantity of green marbles. The ratio of the number of yellow marbles to the number of green marbles is 1 to 3. So let's once again try and visualize that. So 1 yellow marble for every 3 green marbles. Now I haven't actually been given an amount, so what is generally helpful if I don't know the exact value of something is to create an expression for myself. So what would the probability of getting a yellow marble be when, well, 1 out of every 3 out of every 4, because there are 4 marbles in total, would be yellow, and 3 out of every 4 would be green. So the probability of getting yellow would be 1/4. The probability of getting a green marble would be 3/4. But let's turn it into an algebraic expression. So if whatever 1 lot is would be x, then whatever 4 lots of that would be 4x. So the probability of getting a yellow marble, the expression would be x over 4x. So let's keep that up here. So the probability of yellow would be x over 4x. So I'm now told that Misha takes at random 2 yellow marbles from the bag. So if I were to do a probability tree, it would look like this. And the probability that she takes 2 yellow marbles is 5 over 84. So I could do the whole probability tree, but that's not a good use of my time because I know the route I'm going to take, which is yellow, yellow. So I know that the probability of yellow times by the probability of taking another yellow ball is going to be 5 over 84. Because when I go along the branches, I multiply. So the original probability of getting a yellow marble would be x over 4x. But it doesn't say that Misha is replacing the marble and putting it back into the ball. So that means that once she takes the first one out, there's one less yellow marble in the bag, and also one less marble in general in the bag. So whatever your algebraic expression is, it would need to be one less for the numerator and one less for the denominator. And you know that when you multiply these two expressions, the end result is going to be 5/84. So let's actually have a go at doing that. So x over 4x multiplied by x minus 1 over 4x minus 1 must equal 5/84. Let's try simplify. So x minus 1 over 4x minus 1 must equal 5/84. Again, let's expand the brackets. So x squared minus x over 4 times 4 is 16, x squared minus 4x is 5/84. Now what I'm going to need to do is do a little bit of multiplying. So I'm going to multiply both sides by the denominator. So let's multiply by 84 first. And remember, when you're multiplying fractions, you only multiply fractions by a whole number, you only multiply the numerator. So that's going to be 84 x squared minus x equals 5/16 squared minus 4x. And then I can multiply by this denominator as well. So 84 x squared minus x is 5/16 squared minus 4x. And now I could expand the brackets. So 84 x squared minus 84x equals 5 times 16. Remember the trick that you can do, double one, halve the other, is going to be 80. So 80x squared minus 20x. And now what I want to do is collect the like terms, or like bring them to both sides. So I'm going to subtract 80x squared from both sides. So I'd be left with 4x squared. I'm going to then add 20x. So minus 84 plus 20 is going to be minus 64x equals 0. So let's write this over here so I have a bit more space. So 4x squared minus 64x equals 0. And now so what I've done is I have created an algebraic expression for my probability. I've then multiplied it and realized it's going to form a quadratic. So when that happens, generally with like difficult questions like this, the aim is form a quadratic, make it equal to 0, factorize it and solve it. So in order to solve a quadratic, you need to make it equal to 0. So it's noticing, oh look, there's loads of x squared terms here. Maybe I could rearrange this to make it look like a quadratic. And if I can do that, I can make it equal to 0, and then I can factorize it. So the last part here is I'm going to factorize it. So I've got 4x is the common factor. So I'll do x here, and then 4 times by something is 64. If you didn't know, you could divide. I happen to know that 4 times 16 is 64. So it would be x minus 16 equals 0. And now if you had normal, like a normal quadratic, like x minus 4, x plus 3 equals 0, you'd set each bracket to 0 and solve it this way. Don't be alarmed by the fact that there's not 2 brackets. If you want to, you can imagine there's a bracket by the 4x. You just set each individual part equal to 0. So first we'd say 4x equals 0, therefore x is 0. So one of our solutions is x is 0. Because this is a real life question in a real life context, that doesn't make sense, because could Cannon have put 0 yellow marbles in the bag if the ratio is 1 to 3? No. So we eliminate that. And we try the next one. X minus 16 is 0, so therefore x is 16. So if x is 16, then Cannon put 16 yellow marbles into the bag. And this is why it's helpful to turn it into a quadratic, because if we're trying to find an unknown, it's much easier to work with an expression. We don't have the values to actually create our own probability. But yes, that's how we do a question like that. Okay, so here we've got a tangent to a circle equation kind of question. So the first thing we want to know about circles, the equation of a circle, is the equation of every circle is x squared plus y squared equals r squared, where r represents the radius and also x and y represent the x and the y coordinates. So I haven't read the question yet, but I know that if x squared plus y squared equals r squared, then for this circle, the radius, or r squared, is 9, which means that the radius must be 3. So what I can do is just draw myself a quick sketch just to make life easier so that I have something visual. And I know that these are going to be the points, because if the radius is 3 and the centre is 0, then that is how the circle would look. So it says find an equation of the tangent to C, and C is the circle, so we want to find the equation of a tangent at the point P1, where P is greater than 0. Okay, so we've got the x coordinate, then the y coordinate. The y coordinate is 1, and P is greater than 0, so I know it's going to be in this quadrant here. So therefore, P could be maybe somewhere like this, and your tangent is going to look like that. And you want every line can be written in the equation y equals mx plus c, so that's what you're ultimately aiming for. So we know this coordinate here is going to be P1, and then it says give your answer in this form. We can ignore that bit for now because this tends to confuse people as well, and then they panic. Don't worry about that. What do they want you to do? They want you to find an equation of the tangent to C, so that is what you need to do. Okay, so the fact that they've told us that this is a circle means that we can use the fact that radius and tangent meet at 90 degrees. This is from circle theorems, and if they meet at 90 degrees, that means that they are perpendicular lines. And if they are perpendicular lines, we covered this earlier in this paper, but just a reminder, perpendicular lines have gradients that times to make -1, or another way of saying it is they are negative reciprocals to each other. So I know that if I could work out what the gradient of the radius is, I could then work out what the gradient of the tangent must be. So is there any way I can do that? Well, what do I know? I know this coordinate is 1, so I know that the y distance is 1. I now need to work out what the x distance is, and I know that P1 is a point on the circle. If it's a point on the circle, then I can use the circle's equation. So remember, this is the circle's equation. X squared plus y squared equals 9. Now here I know the x coordinate is P, so I could say P squared plus 1 squared equals 9. I've just substituted the y coordinate into the equation, so therefore P squared, if I take 1 squared away, which is just 1, P squared is 8, so therefore P must be the square root of 8. Again, this is one of the end questions on the exam, so don't be alarmed or surprised if you see surds. It doesn't mean you're wrong, it just means they've just tried to make the question a little bit harder. So that means that the x coordinate is 8. Now, how do we work out the gradient? The gradient is the change in the y coordinate, which is 1, over the change in the x coordinate, which is 8, because I'm starting from 0, that's how you can work out what this distance is. So the gradient of the radius is 1 over root 8, and if the gradient of the tangent is its negative reciprocal, reciprocal is when you flip the fraction, so let's flip the fraction, it would become root 8 over 1, and I'd put a negative sign in front of it, but anything over root 1 is just itself, so I can just write that as negative root 8. And as you can see, there's going to be a lot of working for this, and you're most likely going to want to make notes and highlight the important bits. That's why I'm leaving the gradient of radius and tangent there. So I know that the gradient of the tangent is minus root 8. And what other key information do I know? I know that P is root 8, and the coordinate that is on the tangent and on the circle is root 8, 1. So I'm just going to rub this out because we need some space. So every straight line is written in the form y equals mx plus c, where m is the gradient, c is the y-intercept, and I have worked out that the gradient of the tangent is minus root 8. So I can then write the equation of the tangent as this. Now, what other information do I have? Well, I know a coordinate that is on this line. So I know that for this line, when x is root 8, y is 1. So I can substitute that in to work out what c must be. That's what we do with equations of a line. If we know the x, if we know an x and y coordinate, the line on the line, you can plug it in and use that to work out the y-intercept. So 1 must equal minus root 8 times by root 8, because x is root 8, plus c. So root 8 times by root 8 is just going to be 8, but it's negative, so it's going to be minus root 8 plus c. So we add 8 to both sides, so therefore c must be 9. And then you've got your equation. So we've worked out what the y-intercept is. We know what the gradient is. So let's substitute that in. So we've got y equals minus root 8 x plus 9. Now it says give your answer in this form. That's fine. Don't panic. It just means we're going to have to do a little bit of rearranging. So what can we do? Well, we know we want the x part to be on the other side. So let's add root 8x. So y plus root 8x must equal 9. Okay, all I've done is move this to this side. And they've given you a little bit of a clue. They said they want it in the form of y plus 2 lots of root something x equals b. And that is because this is a surd. And if it's a surd, it means it can be simplified. So remember, we're looking for the square numbers, 1, 4, 9. I know that root 8 is root 4 times by root 2. 4 times 2 makes 8. Root 4 is 2, so that would become 2 root 2. So instead of saying root 8, I would say y plus 2 root 2x equals 9. And that's it. That's how I've got it in that form, where a is 2 and b is 9, and they're both integers. Okay, so we've got our final question here. So we've got some slight problem solving with negative and fractional indices. So we need to find the exact value of x. So let's think about what we can do here. Well, first of all, whenever we're multiplying, simplifying, dividing, doing anything with indices, they need to have the same base in order to apply any of the index laws. All of these have a different base, but I know my 4 times tables, and I know that they are all multiples of 4. So that is probably where I'm going to want to start to make my life a lot simpler. In order to use any of the index laws, they're going to need to have the same base. So how else could I write 16? Well, I know that 16 is 4 squared. And the reason I've chosen 4 is because I've got 4 here. I also know that 4 cubed is 64, so that's why. It could have been 2, it could have been something else. You're going to look for whatever is common to all of your things. So instead of 16, I would say 4 squared to the power of minus a half equals, and instead of 64, I would say 4 cubed to the power of a quarter. I've just rewritten these integers as powers of 4. divided by 4 to the power of x plus 2. So now let's simplify. Remember, the law of brackets is that you multiply the powers. So 2 times by minus a half would be minus 2 over 2, which is minus 1. So that would be 4 to the power of minus 1. 3 times a quarter would be 3 quarters. So that would be 4 to the power of 3 over 4 divided by 4 to the power of x plus 2. So I've got them now all to have the same base, which makes my life a lot easier. And now that they have the same base, I can use the laws of indices again. So I know that 4 to the power of minus 1 must be equal to these two simplified. Now, what do you do when you're dividing indices? You subtract them. So 4 to the power of minus 1 must be equal to 3 quarters minus x plus 2. And some people get a little bit stuck here as well. When you're subtracting like two terms, you're going to end up subtracting them both. So sometimes it's better to put them into a bracket. Imagine there's a minus 1 in front of it, and then expand it. So that would be 4 to the power of minus 1 is 4 to 3 quarters minus x minus 2, because minus 1 times 2 expands that way. Now, hopefully you can see that this must then be equal to this, because they're equal to each other. So 4 to the power of minus 1, whatever this is, it must simplify to make minus 1. So now I've got an equation that I can write. I know that minus 1 must equal 3 quarters minus x minus 2. And let's see what we can do here. So first of all, let's just make our life easier. I'm going to move x onto the other side. So minus 1 plus x is 3 quarters minus 2, just because it's nicer and easier to have a positive x. And then I can add 1 to both sides. So x is going to be 3 quarters. Minus 2 plus 1 is minus 1. And what is 3 quarters minus 1? So again, some people get a little bit stuck here. If you get stuck with that, turn 1 into quarters. So 1 whole is the same as 4 over 4. And the reason I've turned it into quarters is so it's the same denominator as this. 3 quarters take away 4 quarters is a quarter. So the exact value of x is 0.25. So it does seem like quite a tricky question, but the key is, if you've got something complicated like this, try and see if you can turn all of the base numbers, which are like the, you know, whenever you have indices, this is the base, that's the power, try to turn them all into the same number. And yeah, that's it. And of course, when I say it's a quarter, I mean minus a quarter. So minus 0.25. 3 quarters take away 4 quarters is minus a quarter. Okay, right. Well, thank you for watching. If you actually watched this and made it the whole way through, then wow, well done. And I hope it was helpful.